Hi, my name is Ifa Fiza binti Hamisa. I can talk about grinding surface machine. Firstly, surface grinding is used to produce a smooth finish on flat surface. It is a widely used abrasive machining process in which a spinning wheel covered in rock particle cut chip of a metallic or non-metallic substance from a workpiece, making a face of it flat or smooth. Surface grinding is most common of the grinding operation. Typical workpiece material include cast iron and mild steel. Three of types surface grinder. First, horizontal. Second, vertical. Third, double disc grinder.
Hi, my name is Fatima binti Radin. My matrix number is CD210133. I will tell about the milling machine. Milling machine is process of machining using rotary cutter to remove material by advancing a cutter into a workpiece. Second, milling machine may be done by varying direction on one or several axes, head speed and pressure. And the last one can be done with a wide range of machine tools. Besides that, I will tell about the types of machine. This machine have 5 types, and the first one is milling machine, often called a mill, as a mill. Second, computer numerical control. People know is machine as CNC. Third, vertical machine. Fourth, horizontal machine center, and the last one is multitasking machine.
Salam sejahtera to and all my friend. I want to present about drilling machine for well special. Many car enthusiasts consider well special a simple way to get perfect upgrade to make a car look expensive. Usually 5mm to 30mm wells tend to be pushed inward to achieve better drag and fuel efficiency. And third is, well spacer provide the space between the well and well hub by slightly them outward. And the differing factor include type, brand of suspension, the right head of the suspension, the size and offset of the well. The design of the tires also could vary slightly depending on the manufacturer of the tires. That's all. And the next is about drilling machine.
Hi, I can talk about product manufacturing process about various grinding method. First, surface grinding. Surface grinding is commonly referred to as a hurricane, and it involves the use of a vertical or horizontal axis grinding machine, a square or circular table, and a strike or cup type wheel. To grind, the workpiece is fixed on a table and the wheel is turned at a high speed. Second, cylindrical grinding is done with either a cylindrical or universal grinding machine. The wheel and the cylindrical workpiece are both revolved and the workpiece outside the periphery is machined. Internal grinding, internal equipment to universal grinder. The workpiece is stationary and the rotating axle wheel is used to the inner surface the workpiece. 4. Centerless grinding. to process the outer periphery of a cylindrical workpiece. Between a fixed blade, a spinning adjustment wheel, and a grinding wheel, a workpiece is supported. 5. Counter grinding is a procedure that involves utilizing a profile grinding machine to form a workpiece into an arbitrary shape.
From this part, I will tell about the milling machine process. Milling machine is a connecting rod is a shaft that connects a piston to a crankshaft in a reciprocating engine. A connecting rod may also convert rotating motion into reciprocating motion. Manufactured by a process that comprises both fogging of a connecting rod, rough fogging, heat treatment, and machine operation. This part show how the piston made. From step 1, rods are cut into proper size from billet and length by using a band saw or billet shearing machine. For step 2, heating of billet into oil fire furnace up to fogging temperature from 1240 Celsius until 1270 Celsius and approx 15 different range of temperature. For step 3, placing billet in between upper and lower die using tong. Fogging into stage, fogging, rolling, and finishing. For step 3, visual inspection is carried out after completion of fogging. After hot fogging, it can produce connecting rod in net shape, less machining operation, which is very adept to both small and large.
Salam sejahtera to Dr. Fuhaho and all my friends. My name is Jessica Jatimin and no matrix CD 210062. Today I want to present about my part is drilling machine. Drilling machine, also called a drill press, is a powerful tool used to cut a round hole into odd through metal, plastic, wood, or other solid material by turning an advanced rotary drill bits into a workpiece. 2. This drilling cutting tool is held in the drill press by a hook and feed into the work at variable speed. The next is the drilling machine can not only be applied in the drilling process, but it is also useful for many other machining operations. And the lastly is various operations can be performed on a drilling machine such as planing drilling, step drilling, core drilling, boring, counter-boring, ramming, countersinking, spot facing, tapping, and the types of drilling machine is, here are some different types of drilling machine. The first is portable drilling machine, hand drilling machine. Second is sensitive drilling machine, bench drilling machine. Third, radial drilling machine. 4, upright drilling machine. And 5, gang drilling machine. And 6, deep mole drilling machine. For 7, multiple spindle drilling machine, and 8 is CNC drilling machine, and 9, micro drilling machine, and the last is turret type drilling machine. That's all for me. Thank you.
Hi, my name is Jamie Zabri and my matric number CD20182. I'm going to talk about flow chart and output. So on the left side is the flow chart with starting and the input and all the process, and the lastly is the output is the machine proceed and the task end. Now I'm gonna talk about the output or the user interface. So when the user want to run program, so they will see this interface. So when they open the software, so they will see the grinding machine assist. So they have to enter the length, the thickness, the width, so that the software will calculate it for the operator. So if the operator key in the the perimeter that is not on the perimeter of the machine, so it will have an error. And if not, the machine will run as it should be. Okay, that's all.
Hi, my name is Muhammad Faiz bin Kamarul Azmi and my metric number is CD210228. Today I'm going to present for a result, which is I going to present the two part. The first one is flowchart and output for milling machine, and the second is flowchart and output for drilling machine. So let's see first at the flowchart, which is from the start, and then we go for the input. So as we can see for the input, we put energy utilization for it, which is 3 kilowatt, and design part which plate with 1 holes, and speed of machines. We have 1 millimeter is less than 3 millimeter, and 4 millimeter is less than 7 millimeter, and 8 millimeter is less than 10 millimeter. So the first is 100 millimeter per second, and the second is 44.44 millimeter per second, and 30.33 millimeter per second. And we go to the next part, which is about the decision. So this is the first decision, which is if C less than and equal 3. So we have two-way, which is if yes, then we get power POW, which is the power is less than 3.142 until 1/200 plus 4 times n. But if more, then we can go to the another step, which is if C less and equal 7. And then if the program yes, then we proceed to the power less 3.142 until 1/33 0.34 plus 4 times n. And if no, we proceed to the next, which is if C less and equal 1. So if yes, then less 3.142 until 1/1 3.33 plus 4 times 6. But if no, and then we proceed to the final, which is machine proceed. And after finish at the yes segment, then also proceed to machine proceed and until the end. And the second is at the side at the right side, which is this is the output. It show the first we must to put our plate on this machine, and the decision part which is plate with 1 hose. And for speed machine, so this is for speed machine, which is we have 3. So as I'm that at the flowchart, which 1 millimeter less than the 3 meters. So, and second is 4 millimeter less than 7 millimeter, and the third is 8 millimeter less than 10 millimeter. And then so we must put the part parameter, which height, width, thickness, whole radius, whole to whole distance, whole and whole distance to each. And after we put the the value for all this in millimeter, then machine can proceed, and after that complete. So this is my second part, which is a flowchart output for drilling machine. So as we can see, from the let's see from the flowchart, yeah, start, and then we go to the input. So this in the orange. This is the input, which is the each of the useful energy is less and equal to kilowatt, and this is for machining speed, which is 40 millimeter, less than 50 millimeter, 20 millimeter, less than 40 millimeter, and less finally is less than 20 millimeter, and the allowed material size. So as we can see, we have 3 OW, L, and T. And from this next part, which is we go to the decision. So decision, we have W less 1000, and H less 1000 until and Y less 20. So if true, then we proceed to the E equal M, and then next is case M, but is false. The statement false, then we proceed to the next step, and then so in next step, if true, we proceed to E equal M, and if false, then we proceed to the next step, which is also the same decision. So we have, as we can see in the flowchart, we have a same decision but different statement for true. And so let's continue. As we can see, the third decision, if true, we proceed to E equal O, and then it labeled as a case O. If false, then we need to make decision, which is we need to enter the size of the model, and then we need to repeat from the first step, which is before we go before we go to the first decision. And then if true, so let's see, if true, then we proceed to the part machine time, total energy consumption, estimated productivity per day, total operation cost, solid waste generation, and this is for the output that we can end until the end. And next, at the right side, as we can see, this is the output that we get, and we have 5 listed FIDs for type of operation that are suggested, which have been suggested. So the first one is drilling operation. The second is boring operation. Third is counter boring operation. Four is the four is reaming operation, and five final is polishing operation. So this five is a suggested operation that we might that we use for a drilling machine. And at the right side, the second page, this is the parameter for conventional drilling process, from the allowed material size, max drilling hole, max drilling speed, max hole to hole distance, and so enter the diameter. This is which is we need to put our diameter, our own diameter based on product that we choose, and the second is hole to hole distance, enter material thickness, input energy for drilling, and lastly is enter radius. So all these value that we put must be in millimeter. And lastly, this is the result as we can see. So that's only for me. Thank you.
Lastly, we're going to talk about conclusion. The task is designing a dev C++ programming code that can be operated on a specific machine. In this project, there are three operational conventional machines that we work on is a milling machine, drilling machine, and grinding machine. During this project, we also face problems like error C code. However, we can fix the problem by doing some research on the internet. The operator only need to enter the diameter of the object and the rate. This will make the operator determine it easier and more accurately. In conclusion, the objective stated was able to achieve successfully.